Yes, student, the question number 18 from miscellaneous. Okay, there's chapter number 6 and the miscellaneous question number 18. I'm going to do it. And based on that, one case study question is there, this which is from cluster paper. Okay, right away. Now the question is, and in the question paper, it's given that a company makes fabrication for automobile manufacturers. It makes a special automobile part in the form of a right circular cylinder inscribed in a right circular cone of radius r. Now the height h and the semi-vertical angle alpha, okay, the alpha and the height h. Right now, let y denote the height of the cylinder. The y denote the height of the cylinder, and let x denote the radius of the cylinder. And we have some 5 questions related to that. So the first question is the relation between the height y and the radius rx of the cylinder and the radius r of the height of the cylinder. Actually, we need to maximize the volume of the cylinder has to be maximized. Okay, but in the question, but in the exercise, it's given that show that the height of the cylinder, okay, show that the height of the cylinder of the greatest volume which can be inscribed in a right circular cone of height h having semi-vertical angle alpha. Okay, we have to prove it in the question number 18. Okay, so let us solve it accordingly. And it is quite easy also. And now based on the similarity property, we are going to solve it. So first one, we are going to consider, okay. So first, let us consider that, yeah. So this is the height, okay, height of the cone. H is being a height of the cone. Now, I'm just going to similarity, I'm going to use it. One is in triangle, considering the triangle APQ and triangle ARC. I'm just going to similar triangles based on the similar triangles. That is a property PQ by RC, which gives you AP by AR. Now, what is PQ? P to Q is nothing but X. X is a radius and Y is the height of the cylinder. Now, what about A to P? So you know that AP, okay, we know that AP is equal to H minus Y, isn't it? AP is what? H minus Y, isn't it? The AP is H minus Y. Yeah. AP is equal to H minus Y. So we shall write what is PQ here? PQ is equal to X divided by R, which is equal to H minus Y divided by what? H again. Height is AR. AR is being H. A to R is a H. And AP is H minus Y. And PQ, what is PQ? It's radius of the cylinder, X. Then RC. RC is considered to be R. Okay. Yes. Now RC is considered to be what? R, radius of the cone. Okay, it's been considered as R, which is a radius of the cone. Let us solve this question. Now, x into h, x into h, now x into h, which is equal to h minus y into r. So, which is x minus y into r. So, now we will multiply what is y equal to, because the first question they asked the relation between the height y and the cylinder of the radius x of the cylinder. Okay, so wait, the relation between the height y of the cylinder and the radius x of the cylinder and the radius r and the height h of the cone is what? We shall find it. So option A, B, C, D. So which is the right answer? We will find it. So now we have got x into h, which is equal to h minus y equal to r. Now in terms of, okay, so now it's very simple it is. We need to write in terms of y because all of them in the option we have got y equal to, right? Yes, we shall write it in terms of y. That is x into h, r into h, r into h, r into y. So r into y. So x into, okay. Now in terms of y, x into h, now r into y, let me take it to other side. Okay. So it will be easy. So I'm going to write r into y, which is equal to r into h minus x into h. So h is being common, so r minus x. So here r into y. So I just write y equal to h into r minus x divided by r. So let us look into the option. So we'll choose the option. Okay, y is equal to h into r minus x divided by r. So here the option C, y is equal to h into r minus x divided by r. So option C is the right answer. Now we go for the question number 17. The radius x of the cylinder can be expressed as what? This is quite still simpler. Let me tell you that. So we know that answer is in terms of tan alpha. We get to see everywhere tan alpha. So we will consider, okay, we will consider now tan alpha itself. And this is being a right angle. You know that this is being a right angle, isn't it? Yes, this is being a right angle, isn't it? Yes, this is being a right angle. And it is right tan alpha, okay, which is equal to adjacent by what? I mean, sorry, opposite by, okay, opposite by adjacent. So this is alpha and P. AP is nothing but AP divided by P. Yes, AP is the adjacent, isn't it? Yes, we write AP is the adjacent, PQ is the opposite. So it is PQ divided by AP. So PQ divided by AP. Now what is PQ? PQ is being X divided by AP is being H minus Y. Yes. Now tan alpha. So tan alpha, which is equal to X divided by H minus Y. Right? Yes. Tan alpha is equal to x divided by h minus y. So x is equal to h minus y into tan alpha. So this is the answer. Let us take it out. What's the option is? So x is equal to h minus y into tan alpha. So option C is the right answer. Now, the volume of cylinder can be written as, okay. Now, the volume of cylinder, we need to find it. Okay. So what is the volume of cylinder? So volume of cylinder, which is equal to pi x square into h. Okay, now I'll write here h is nothing but your y, height, right? So pi x square y is a volume of cylinder, but here we already found out y is nothing but h divided by, we already found, isn't it? So y is nothing but h into r minus x divided by r. Now let us substitute. So h into r minus x divided by r. So I have substituted. Okay, I just substituted in terms of y. Okay, then what to do here? Now we already with the form. Now what's common? Yes. Now what can be done here? Yes. Now pi into x square we have it. Okay, into h by h divide into r minus x divided by r. Okay, moreover, I can't do anything, but they asked volume of cylinder. Let us check the option whether we are getting it wrong, right or wrong. So pi x square h into pi h into, actually here they've given, we can take x square common. Okay, v is equal to pi into h divided by r, and here x square I can take common, and here what happens? R minus x. And is it same? Yeah. Yes. So this is the right option. Option B is the right one. So volume of cylinder will be maximum when? Okay, then we have to differentiate, right? Now we have to differentiate. So dV with respect to dy. So that is pi is a constant. Yes, h is a constant. Then r is a constant. Yes. Now what we have it? Now how do we differentiate? Okay, we are going to differentiate dV with respect to dy, isn't it? Yes. And here dy is nothing but here r. We have, okay. So how shall we differentiate? So 2r, and first we will write down in this format because pi hr is a constant, and we can differentiate it easily if, yeah, we Okay, because in the whole term is expressed in terms of x only. So dv with respect to dy, dx we will do it. Yes. Yeah, we can do it like we can use this statement b is equal to pi into h by r, and you're going to differentiate with respect to x itself. So pi h is constant divided by r, and here x square into r, right? So that is r is a constant again. So 2rx minus here 3x square, right? Yes. Now next we have to double differentiate. We shall do the double differentiation. Okay, that is pi h divided by again r is constant. So 2r differentiation of x is 1 and 3 2s are 6x. Now we will equate to 0 dy by dx, dv by dx. Okay, dv by dx is equal to, okay, dv by dx is equal to 0. Now we find the critical point. So that is pi h by r into 2rx minus 3x squared, which is equal to 0. So r into 0 is 0. Now 2rx minus 3x squared equal to 0. Now 2rx, which is equal to, okay, 3x squared. So where the one x terms also get cancelled. So therefore x is equal to 2r divided by 3. Yes. So, well, let us check out the volume of cylinder maximum when x is equal to what? So 2r by 3. So option A is the right answer. So what is the volume of the cylinder when x is equal to 2r by 3? So we will find out right away. So when x is equal to 2 by 3, the maximum value of the cylinder, the maximum value of cylinder will be pi h, okay, pi h, pi h divided by r, okay. Now r into 4r square by 9 minus 8r square by 27. Yes, we are going to substitute in the initial equation. Okay, that is v is equal to, we got it right, which is the initial equation. Consider this equation. We just going to substitute wherever you find x, you're just going to substitute. And then you're going to get this value. Okay, you're going to get this particular value. Simple, simple. Now pi into h divided by r, and the r cube, you get to see r into r square, right? So r square is r cube, but r square into r is r cube. You can just take it out because here also you get, yes, r square actually common. Okay, so r square, you can get it out. Okay, so what happens here? Yes, this is a r cube, so I can take r cube out. So what happens here? 4 divided by 9 will remain, and 8 by 27. Okay, when I take LCM, and I would get 4 by 27, work out on this, you get 4 by 27, and pi into h into, and r square. Okay, pi into h into r square, 4 by 27. Okay, so now, and now the answer, we will check it. So that is a pi into h into r square, where we get 4 by 27. Yes, somewhere we are lagging. So we will write the r square. We just write, we are lagging somewhere. So we are not getting the answer. So pi into h. So we write r. R is equal to what? I mean, yes, r is equal to what? We wrote here x is equal to, yes, h minus y tan alpha, right? Yes, where r is equal to what? So we have to write it. So r is equal to, in terms of tan, we have to get the answer. So what can be done? Yes. Okay, we know that that is r divided by h, which is equal to tan alpha. So r is equal to h into tan alpha. So we will substitute here h into tan alpha, okay, 4 divided by 27. So the whole square. So pi into h square into h is h cube. So tan square alpha into 4 by 27. So the standard format is here 4 by 27 h into h cube tan square alpha. Option C is the right answer. Yes. Thank you for watching the video.